Okay, so last section for this week is 4.3. So we're still looking at rational equations. We're going to look a little bit at rational inequalities, but we're not going to focus on graphing them as much. We're going to focus on solving equations. Okay, and a little bit with inequalities, but mostly focusing on equations. Okay, anything that we do look at graphically, we'll probably just use the calculator rather than do as much sketching by hand. Okay, because we did a lot of that over the past couple of days. All right, so the problem we're going to look at in example 1 involves the distance formula. Does anybody remember what the distance formula is? It has three letters in it. Starts out D equals, distance equals, there's two other letters.
It's rate and time.
Rate, and what do you do with the rate and the time?
You multiply them.
You multiply them, yep. So distance equals rate times time. All right, so that's our distance formula. And we're going to use that in example 1. Okay, so as far as example 1, you really don't need to write down the whole problem. You just need to write down like the key numbers. So Sue is driving 30 miles to a train station. Okay, so Sue drove 30 miles. She's taking 2 modes of transportation. She's driving some of the trip, and she's going to take the train for the rest. Total distance, 120 miles. Okay. And we know that the average rate of the train is 20 miles per hour faster than the average rate of the car. Okay, so the important things, Sue drove 30 miles. Total trip is 120 miles. The train goes 20 miles per hour faster than the car, on average. Okay, so those are the three things you need to know. And what I want to try to do is find an equation that represents the amount of time it's going to take for her to complete the trip as a function of x, where x is the speed she drives in her car. All right, so when we're done, we'll have a formula that says, all right, suppose she drives 33 miles an hour average. How long would it take her to complete the trip? We'll be able to plug 33 in for x, and it'll take into account everything we said in this problem and figure out her speed, or her time it takes to complete the trip. All right, so we need a formula for time as a function of x. So looking at our distance equals rate times time, what is time equal to? Yeah?
Distance over rate.
Right, it's distance divided by rate. Now, how many different rates do we have in this problem? We have 2. We have the rate of the train and the car. So there's 2 different modes of transportation. And if we want to find the total time it takes, what would we have to do with the time it takes for her to drive and the time she's on the train? We'd have to add them. So we need time in car plus time on train. Okay, so we have to figure out both of those. So let's start with the time in the car. Okay, time is equal to distance divided by rate. Do we know the distance she drives in the car?
30 miles.
30 miles. Divided by, do we know the rate that she drives in the car? Or do we have a way to represent it? Allie? Okay, did they suggest a variable for us to use? Yeah, it says x is the speed of the car. All right, so we're going to let x be the speed of the car, but that's exactly what we need. It's a variable, and if they didn't suggest it, you could use anything you want. Okay, any questions on that? So we've got distance in the car divided by speed of the car. Do we know the distance that she's on the train for? Trevor, what's the distance on the train? 90. How did you figure that out?
Total minus the distance of the car.
Yeah, she's traveling a total of 120 miles and she's doing 30 by car, so the 90 is the remainder, which is on the train. And now, do we have a formula for or an expression for the speed on the train?
20 X.
Yeah, 20 plus x or x plus 20. Let me see how I wrote it. I wrote it as x plus 20. So it's 20 miles per hour faster than the speed of the car. And that's it. There's your time as a function of the speed she drives in the car. Okay, and we'll do a couple things with this in a little bit. But any questions on that?
Are we solving?
What's that?
Are we solving?
In a minute, I'm going to give you some more information. Like I could say, I could give you two things. I could say it takes her 2 hours to do the journey. How fast did she drive in the car? How fast was the train going? Or I could say she drove 50 miles an hour in the car. How long did the trip take? So we could do it either way. Right, so I want to look at that formula we just came up with and analyze it just like we've done the other graphs. Okay, let's find some asymptotes, the roots, end behavior model, and find a complete graph. That doesn't mean sketch by hand. Okay, that means do it on the calculator. All right, so this is the kind of problem we've looked at in homework a couple nights where we've got two separate fractions. But what do we usually like to do when we have two fractions that are separate? Yeah, let's combine them together so that way we can look at end behavior models a little easier and stuff like that. Okay, what's my common denominator here? Yeah, x.
Square. Would be
Well, let's leave it factored.
Oh,
Just because that's going to help us, I think, to find the zeros a little easier.
would it be x times x plus 20?
Yeah, x plus 20. So now I look at each fraction and see what it's missing. This one's missing x plus 20. And this one is missing the x. All right, so the denominators are already done out, x times x plus 20. What about my first numerator?
It's going to be 30X.
Yep.
Plus 6.
Plus
600.
600. Yeah. And my second numerator? 90x. All right, so now we'll combine it together. And then we'll have a version where we have everything combined, and we still have the original where it was separate. Maybe we could use the original for some stuff, but at least we have a combined one if we need it. So 120x plus 600 over x times x plus 20. All right, let's do the vertical asymptotes. Okay, where are my vertical asymptotes going to be? Yep, you're going to have one at 0. And where else? Negative 20. So I'm not saying that that makes sense in the context of the word problem, but that's what they are. Now, the only thing we'd have to check to make sure we don't have a hole at negative 20 is if you factor the numerator, would it end up being x plus 20 in the top? I think you could see the answer would be no. Because if you factor out 120 from each term in the top, you'd be left with x plus, what happens when you take 120 out of 600 with division? 5. Okay. So the top would factor as 120 times x plus 5. No common factors in the top and bottom. Okay. What's my end behavior model.
One
120x over x squared. And if we reduce that, what do I get? Over, yep, x. Now I can let x approach infinity in that fraction, and that tells me my horizontal asymptote. What's my horizontal asymptote? 0. All right, so we've got those, those. What else do they want? We got all the asymptotes. Find the end behavior model. We got that. The zeros. Right. So in order to find the zeros, what do I have to do for that? What does that mean? Find the real zeros. Okay, another way to word it is find the x-intercepts of this graph. So how would you find where this graph crosses the x-axis? Think of any coordinate on the x-axis. What do they all have in common? Yeah?
Where y equals 0, so you set the expression equals 0, and that's all.
Right. So to find the zeros or to find where it crosses the x-intercept, that's where your y value is 0. So basically, if you set that fraction equal to 0, what's the only way a fraction can equal 0? If what? If the top is what? If the top is 0. Okay, so to find my zeros, just set the top equal to 0. So 120x is it plus 600 equals 0. And where is this graph going to cross the x-axis? -5. Again, what does that mean in the context of this problem? Well, not much, because that's negative speed. But they asked us to find it, so we found it. Okay, so we got our zeros, asymptotes, end behavior model, and now we'll graph it. To graph it, you could type in either the original or the one that we combined. I'll just do the one that we combined. Okay, so we've got 120x plus 600 divided by x times, and I do need parentheses again, x plus 20. Okay, what's a minimum value for x that would make sense? Yeah, 0, even just above 0. Because what would happen if she drove 0 miles per hour? So how long would the trip take?
Long time.
Long time. Okay. As far as a maximum, we don't have a maximum speed, so let's just set it to 60 and see if that's enough for what they're going to ask us next. Time, can it take negative time to do the trip? Nope. And as far as maximum time, we don't know, okay? But we do know we're measuring our time in, we had miles and then miles per hour. Okay, so we're measuring our time in hours. So we can leave it at 10 hours and see what it looks like. And let's do a standard window. Actually, you know what? No, leave the window the way we set it. That's fine. Okay, so notice what's happening to the time it takes her to complete the trip as she goes faster. Yeah, it decreases. And the horizontal asymptote in this problem should really make sense that it's approaching 0, because the faster that she goes, her time is getting closer and closer to 0. Okay, it's getting smaller and smaller. Right, so any questions on the graph? Oops. All right, so now we don't even see the asymptote or the x-intercept. So there's a whole nother half to this graph we're not seeing, but we don't have to worry about it because it's a word problem. Okay. So now it says Sue has 2 hours to complete her trip. Find the speed she must travel by car. Okay, first we'll do it algebraically, and then we'll use our graph to do it. Okay, how would I find the speed it's going to take to complete the trip in 2 hours algebraically? Think about where would 2 get plugged in? Does it get plugged in on the left, or does it get plugged in for x? Yeah? For t of x, yeah. Plug it in for t of x. It doesn't matter which version you use. I'm going to use the one that already has a common denominator because I think that'll save me a step. So the time equals 120x plus 600. And we're going to divide by x plus 20. Okay, any thoughts on how I would solve that? What do you think I would do first? I mean, one way to think of it is as a proportion. I wasn't really thinking of it that way. And you could do something. Or because the denominator in that proportion would really just be a 1, you only really need to do half of what you would do is if this wasn't a 1 in the denominator. Yep.
Could you multiply both sides by the denominator?
Yeah, you really just need to multiply both sides by x plus 20. Okay, so it's x plus 20 on the left, and then x plus 20 on the right. That's going to cancel out your denominator. And Quinn, what is that going to leave me with if I do all this out on the left?
X times 2x plus 40.
Yep, and can you go ahead and do that part out as well?
You multiply it by x.
Yeah, let's get rid of all the parentheses there.
So 2x cubed plus 40x squared. Or
2x, what's that exponent going to be?
squared
Squared, yep,
plus 40.
plus 40x. Okay, so really you're just distributing a 2x to everything. So 2x squared plus 40x equals 120x plus 600. Okay, Andrew, what would be my next step?
Set everything equal to 0.
Yeah, let's get everything equal to 0, and I think it's probably good to get everything on the left. Can you tell me how to move everything to the left?
Subtract it.
Yeah, subtract this one and
The 600.
a 600. Yeah, subtract everything. Okay, so I'm going to be left with 2x squared. What's 40x minus 120x? Negative 80x. And now what kind of equation do I have? Oh, Jeff? What kind of equation? Yeah, it's just a quadratic. So before we solve it, we could reduce everything by 2. Just make everything a little smaller. I still don't think this is something we're going to try to factor. We're just going to use quadratic formula. Okay, Rachel, what's A? 1. Francisco, what's B? Negative 40. And Pacey, what's C?
Negative 300.
Negative 300. All right, so we're going to do quadratic formula. We know we're going to get 2 answers, but keep in mind one of them is usually positive, one of them is negative, and we're driving in a car. So we should be able to figure out which one doesn't make sense. So we got negative B plus or minus the square root of b squared minus 4ac all over 2. Now we're going to subtract a negative, so that's going to turn into a positive. What's 1600 times 300? Oh, I'm sorry. What's 4? Yeah, we don't need to do that. 4 times 300. 1200, and then plus 1600. 2800. Yeah. Okay, and divide by 2. We got to round this off now. Okay, the square root of 2800 is about 52.92. Now, in terms of the plus and minus, we're talking about the speed we're driving in a car. I only need to look at one of the answers. Is it the plus or the minus? Yeah, if you do 40 minus 52, you're going to get a negative. So we don't need to worry about that one. So now do that out, and that's the speed. 40 plus 52.92 divided by 2. So she's going 46.46 miles per hour. So that's algebraically.
It's in the car, right?
That's the speed, that's x. That's the speed in the car. Did they ask for the speed in the train?
No, I think we just
It would just be 20 more if they did, but they did ask for car. So. Now, how would I do this graphically? What would I have to do? That's the graph of my times, and I want to know where the time is equal to what?
2, so you put a line at y equals 2.
Yep, put a line at 2 and see where it crosses. And now you'd calculate what? Calculate an intersect. I did something wrong. So second calc, intersect, pick a point on the blue, red, guess, and we get an intersection point at 46.46. Okay, so that's how you do it graphically. Now, there is another place that this line would cross, and it's somewhere in the negative section. So as I said, there's a whole other part of this graph we're not even seeing, but it's not important in terms of the word problem. Okay, any questions on that? So make sure you're comfortable with both methods. Either if I ask you to show your work algebraically, or if you just can do it graphically, that is faster. Or even just to check your answer. It's a nice way to check it. All right, so in that example, we multiplied both sides by a variable. Okay, we multiplied both sides by, I think it was x plus 20. Okay, anytime you do that, you've got to be careful that you don't get an extra answer in your problem that doesn't work. Okay, so anytime you multiply both sides by a variable, you can get an extra answer that doesn't work in the original problem. Okay, and that's called an extraneous solution. Okay, so an extraneous solution, it's a solution to the equation you created by multiplying both sides by a variable, but it is not a solution to the original problem. And I could show you a very simple example. What's the solution to that equation?
4.
Yeah, it's 4. Okay, if you plug 4 in for x, you get a true statement. Now I'm going to multiply both sides by x. Okay, I just created a new equation, multiplying both sides by a variable. Does 4 still work? Is 4 squared equal to 4 times 4? Yes, of course. 4 still works. But there's another number that works here now. Anybody see what other number you could plug in for x? Negative 4 wouldn't work. That'd give you 16 equals negative 16. 4 works. Yeah, so that's the one we originally said. Yep. 0. Now 0 also works. 0 squared is 0. 4 times 0 is 0. 0 works in the new one because I multiplied both sides by a variable. Does 0 work in the original? No. I created an extra answer, and that's an extraneous answer. Okay, so that's the kind of thing that can happen. A little more complicated with a rational function, but the exact same idea. All right, so the only way you know that you have an extraneous solution is to check your answer. Okay, I was going to show you an example with this equation, but I already showed you with the one above it, so I'm not gonna do this one. Okay, generally, when you have a rational function, you can tell something's extraneous because it causes you to divide by 0. Okay, so as we're solving this problem, if I get 1 or 3 as an answer, it's extraneous. Because if I plug in 1, that would cause me to divide by 0, so would 3. So we'll just go through and solve it and see what happens. All right, so the goal when we're solving a rational equation, we're not trying to find common denominators. We're going to try to get rid of all the denominators. And I'm always going to set it up so something special happens. Does anybody notice the connection between the denominator on the right and the 2 on the left?
It's just the fact that if you multiply both the denominator, they'll probably give
Yeah. If you multiply x minus 1 times x minus 3, you get this, x squared minus 4x plus 3. So what does that mean this would factor into? Yeah, it's x minus 1, x minus 3. That's always going to happen with these kind of problems. If it didn't, it would be kind of complicated. So my goal is to multiply each term, okay, this one, and that one, by something that would cancel out all the denominators. And I have to multiply by the same thing everywhere. So does everybody see what anyone see what I could multiply by that would cancel out all my denominators? Well, think what you would have to put in the numerator of each fraction. Look at the first fraction. Think what would have to be in the numerator to cancel out the denominator there. Okay, look at the second fraction. See what would you have to put in the numerator to cancel out what's in the bottom there. And then look at the third fraction. And say what would you have to put in the numerator here, what 2 factors, to cancel out what's in its denominator. So what do we need? What do we need in the top of the first fraction to cancel out what's in the bottom? Amanda?
X minus 3.
A first fraction.
X minus 1.
You need an x minus 1 here to cancel out what's in the bottom. Okay? And if you put an x minus 1 here, you have to put it here, and you have to put it here. Okay? What would you need in the second fraction to cancel out its denominator?
X minus 3.
You'd need an x minus 3 in the top. But if I put it there, where else do I have to put it? I've got to put it everywhere. And now, what would I need in the top of the third fraction to cancel out what's in the bottom? I already have it. Okay? It just happened because of the way I set the problem up. So now, let's do it out. I'll cross out what's going to cancel first. That cancels that. That cancels that. And that cancels all of that. So let's start with the right-hand side, because that's the easiest. What's left there? 2. Now, on the left, you're going to have to use distributive property. Okay, you've got 2x times x minus 3. So what's 2x times x minus 3? 2x squared minus 6x. And now this one's pretty straightforward because you're just distributing a 1 to x minus 1, so it stays the same. The only thing that can be a little tricky here is if this symbol is a negative, that is part of the 1. Okay, that negative would get distributed. All right? And if it if it's confusing, what I usually do, if I have, let's say I had something like this, minus 1 over x minus 3, put the negative with the 1 instead. Okay? Then you can see, oh yeah, that negative goes with the 1 and distribute it that way. Okay, so any questions on that if that's a negative? Move the negative up with the number if you want, and then make it a positive. All right, now what kind of equation did we basically, or are we going to end up with in a second? Yeah, another quadratic equation. Okay, so get everything on one side. So I'm going to get 2x squared minus 5x minus 3 equals 0. And will that one factor? Yeah, let's try and see what happens. We get 2x and x. Okay, what would my signs have to be? Plus and minus, and I'll try them in that order. And two numbers that multiply to give me 3?
1 and 3.
1 and 3. So I get 2x squared minus 6 plus 1 is minus 5. And then positive 1 times negative 3. Perfect. Okay, so what would make the first factor 0? Negative 1/2. What would make the second factor 0? 3. And now before I circle those answers, I got to check to see if they're extraneous. 3 cases can happen. They both work. They both don't work. One works and the other one doesn't. Okay. Let's check 3 first. Can I plug 3 into the original? No. That would cause me to divide by 0. So that is an extraneous answer. Let's check negative 1/2. Would that cause me to divide by 0? No. Then it would work. Okay? Assuming you didn't make an arithmetic mistake. If you want to check your arithmetic, you should plug in the negative 1/2 everywhere and do it out and check it. Okay, but all I'm checking for to do it a little quicker in class is it extraneous because of a divide by 0? No. Okay, and if I check the book, that what we did is correct. Okay. Questions on that one? Okay, so I know I make it probably seem very simple, but on the test, this is a question a lot of people usually mess up. I think they just forget to distribute. Like they'll do 2x times x and write 2x squared, but then they don't distribute 2x times negative 3. They start off good, like multiplying everything by what they should, but then the distributive property gets all messed up. So just be careful when you do the distributive property. And if you do that right, most people do the factoring right. Okay, that part's not as bad. Or quadratic formula. All right. So same type of problem. This time it's equal to 0. That's fine, because eventually I would probably move everything to one side anyway to get it equal to 0. So that already did that step for me. All right, so what would I have to multiply everything by here to cancel out all my denominators? Amanda?
For the first one, you multiply the top by x.
Okay, so x, and I got to do it here and here. And I need an x plus 2 to cancel out the second one. And I got to do it here, here, and here. And what about the third one? It's already going to cancel out because that denominator was a product of the other two. So plus 6. What's going to cancel in the first parentheses? X's are gone. What's going to cancel in the second? X plus 2's. So now we got to do FOIL here. X minus 3 times x plus 2. So x times x, x squared. X times 2, minus 3x. Negative 1x. And negative 3 times 2, negative 6. That's going to be kind of nice. And that's the first one. And now the second one is just 3 times x. Okay, -6 plus 6. So this one, we got rid of our constant, so you never need to factor a quadratic formula if you don't have a constant. We can, well, you don't have to do the complicated factoring. It's going to be a lot simpler. X squared plus 2x equals 0. And now I can do a simpler kind of factoring. Just take out what they have in common, which is x. And what does that leave me with? X plus 2. So what are my 2 roots? Okay, now before I circle them, I'm going to go back up and check them. Can I use 0? No, can't use 0. That'd be a divide by 0. I can't use -2. That would be a divide by 0. So both answers are extraneous. This problem has no solution. Unfortunately, there's no quicker way to tell algebraically. So, okay, on the test, most likely you'll have one that at least one of the answers does work. So you'll have at least one work. Okay, questions on that? All right, so now we're kind of getting into the last part here, which is shifting into inequalities. All right, so I'm not asking you now an exact question, like what speed does she have to travel at to complete her trip in exactly 2.5 hours? I'm asking 2.5 hours or less. Okay, so now we're getting into an inequality. All right, so what I need the original equation that we had when we did this problem, preferably the one with the combined denominator. So anybody tell me what that was? It was like 120x plus 600 or something?
Yeah, 120x plus 600 over x times x plus 20.
Okay. So that was our equation. Okay. Now I want her time to be less than how much? 2.5 hours. So I want her time to be less than 2.5 hours. Now, I'm going to graph it. I can't multiply both sides by x plus 20 like I did with an equation. Why not? And maybe in this problem I could because it's a word problem and I know a little bit about x. But if this was just an equation without a word problem or an inequality, why can't you multiply both sides by a variable when you have an inequality? What could happen when you multiply both sides by an inequality? A basic thing from Algebra 1. Allie?
To multiply both sides by negative, you have to flip the sign. You don't know about the variable.
Right. If you multiply both sides by a negative, you need to flip this inequality. But as she just said, if you're multiplying both sides by a variable, you don't know if you're multiplying by a negative. So we can't do that same approach. I'll show you what we can do in a second. But for this problem, let's just graph it. So I already have my equation typed in from before. I'm just going to change 2 to 2.5. Since she's allowing herself a little more time, that means she could drive at a faster or slower speed. She could go a little slower now. So how would I solve this? What would be my first step? Okay, find the intersection. Okay, so that's 34.88. And what would my answers be for my speeds? Would it be speeds faster than that she could drive or slower than that?
Oh, faster than
Well, she has to complete the trip in 2.5 hours or less time. So she has to drive at that speed or faster. Okay? If she starts to drive faster, she's going to end up down in this section. If she went slower, she wouldn't complete it in 2.5 hours or less. Okay, so graphically, it's pretty much the same. Find the intersection point, but then decide, should it be a greater than or equal to, less than or equal to. Now, technically, did it say less than 2.5 or less than or equal to 2.5? All right, it said strictly less than, so really she has to drive faster than 34.88 miles per hour. Technically, so you should write it that way. All right, so what we just did was we solved a rational inequality. Okay, remember from the kind of problems we looked at yesterday, you can have hidden behavior. So what I mean by that is you can have a section that looks kind of flat, but if you zoom in, it might actually be pretty wavy. Okay, so always make sure you look at behavior that looks like suspiciously flat. Look for things that are off the screen. That's also hidden. So always make sure you're seeing everything you need to see, especially if it's not a word problem. Word problems can be nice sometimes because they restrict what you need to look at. A lot of times negatives don't make sense in word problems, so you don't even need to think about them. Okay, when we're solving something algebraically like this problem, we can't multiply both sides by something with a variable, but what we can do is make a sign chart. Okay, and we've done this method before. The sign chart method is dependent on you being able to factor it. If you get a problem that doesn't factor, you have to use the calculator. Okay, you can't use the sign chart. Now, when I use the sign chart method, I usually don't try to get the number 1 on one side. What number do we usually want on the right or the left side? In this case, it's the right. We want 0. So how would I bring this 1 to the other side? I'm going to subtract it. Now, I'm going to subtract 1, but I'm going to hold off on writing it right now. I want to get a common denominator. So can anybody think how I can write the number 1 with this denominator? Just think about when you divide, how do you get a 1? Yeah?
Would you put x squared plus basically the denominator as the numerator and the denominator?
Yeah, so I'm just going to find a common denominator all in one step. This fraction right here has to be a 1. Okay, the easiest way to make it a 1 and a common denominator is make the numerator and denominator the same. And 2x squared plus 5x minus 3. Now I've got two fractions. I brought the 1 to the other side. This is a 1. And now we can combine like terms, and hopefully everything will factor nicely. So we get 2x squared plus 5x minus 3. What's something you think I need to be careful about? I've mentioned a couple times when I try to combine these fractions together. Something a little tricky people forget sometimes. Yep?
That it's minus, so you have to distribute the negative.
Right, that is distributed to every term. So let's go through it. What's 2x squared minus 2x squared? All right, so that's gone. What's 6x minus 5x? And what's negative 8 minus 3? Negative 5. So the top is already factored. Okay, when you use the sign chart method, you have to get linear factors. There's 1. And I think the bottom we already factored earlier. Okay, how does the bottom factor?
2x minus 1, x plus 3.
Let's check. Get 2x squared plus 6x, take away 1, that's positive 5, and negative 1 times 3, negative 3. Perfect. So now, from here, we're going to make our sign chart. Okay? For those that are really comfortable, you can just jump right to the final answer. I'll go through it step by step if you need to. What value would make this first factor 0? 5. What if you plug in numbers bigger than 5? What do you get? Greater than 0, you get positives. What if you plug in a number smaller than 5 for x? Negatives. All right, let's do 2x minus 1. What value would you plug into 2x minus 1 to get 0? A half. Plug in numbers bigger than a half for x, you get positive. Smaller than a half, negatives. And x plus 3. What gives me 0 in that factor? Negative 3. Plug in numbers bigger than negative 3. You get positives. Plug in numbers smaller than negative 3 for x. Negatives. And now this is the part I was saying you could have just jumped right to if you already understand all that. Make your final number line with negative 3, 1/2, and 5. Let's check what happens if we put in a negative 3 in all of these factors. Okay, let's start with the top factor. What if you put a number that's less than negative 3 in the first one? You get a negative over, let's do the second factor. Plug in a number less than negative 3. Another negative times, and now let's do the third factor. Less than negative 3, negative. What does that come out to? Yeah, that's a negative divided by a positive. What's the behavior in each section? How does it work? It should just alternate. So we can check one more, make sure we get positive, and then if we do, we'll just go negative, positive, negative, positive. Let's check between negative 3 and 1/2. Okay, between negative 3 and a half in the first one. So negative. Negative 3 and 1/2 in the second. Negative. And between negative 3 and 1/2 in the third. Positive. That's a negative divided by a negative, which is a positive. So it's just going to alternate. Just like that. And now we are looking for, where is this thing negative? Where is it less than 0? Okay, where does that happen? Yep, in fact, let me write it exactly the way Trevor just said it. Negative infinity to negative 3. Or where else? 1/2 to 5. If it could equal 0, it wasn't strictly less than, I would have used a bracket on the negative 3 and a bracket on the 1/2 and a bracket on the 5. Always parenthesis on infinity. Or negative infinity. Okay. Any questions on that? All right, so the last one we'll finish up with strictly a graphing problem. Because the numerator is so complicated, I think this would be kind of difficult to factor, so I wouldn't expect you to make a sign chart for it. We'll just type it in and see what we get. All right, so if I want to do it like I did the last problem, what would I have to move to the other side? The 15. I don't need to find the common denominator. The calculator can handle all that. But I would have to move that. So let's type in x to the 4th minus 3x cubed plus 2x squared plus 2, that's my numerator, divide by x minus 2, my denominator, close parentheses for that whole term, and what am I going to subtract from it? Subtract 15. Minus 15. And we're going to look for where this graph is greater than or equal to because we subtracted the 15 now. So what's on the right-hand side? 0. Okay. You don't have to do it that way. There's other ways we've talked about to do it, like looking for an intersect and putting something in y1 and y2. But we decided to move everything to the left. All right. So let's graph it. All right. And it's still going. Oh, is that? I think that's left over from another problem. All right. Well, I'm trying to look where this is above 0. Is that a good window?
No.
No. Let's do the standard window and start with that.
Mr. Hager?
Yes.
So y equals you have 2 parentheses in the beginning, but only 1 at the end.
Double check.
No,
So
it's the whole thing's one big parenthesis, right?
Yeah, but you didn't add 1 at the end.
It does.
You did?
It's right after x minus 2.
No, minus 15.
yeah, I don't need one there because I've got my x minus 2 opened and closed. And then I've got, if you go back to the polynomial, I've got that one. Maybe I'll show you. I've got that one open and closed, and then I have the big one on the end and on the beginning. Yeah. So I have 2 lefts. Yeah. Is everything good there? Yeah. 3 left parentheses and then 3 right parentheses. That's how I count. Make sure you have as many lefts and rights. All right. So where is this above 0? Well, just let's zoom in a little bit just to make it a little easier to see. Okay, and I'm just going to have to calculate where we are above 0. So second calc intersect and try to find where am I? There I am. All right, so pick a point left. Pick a point somewhere to the left, which I think I am. Yeah. Pick a point to the right. And I get 2.22 as one of the roots. Now, what value do I have to be careful about in the denominator that I can't use? Two. I can't use 2. Right? So I can go from 2 up to 2.22. And actually, I can equal 2.22, so that's okay. I just can't use 2, because if I tried to, that would be a divide by 0. So that's why I didn't put a bracket on 2. Or I can go from, calculate the other root, pick a point left, right, guess. It should be, oh, I typed it in wrong. Well, it should come out to 2.68 to infinity. I messed up my guess or something. Okay, and that's your answer. All right, so tomorrow we have our test. It'll cover everything we've done this week from very end of chapter 3, 3.7, which is solving systems graphically, all the way up to 4.3. Homework's on 244. Okay, 1 to 9, just the odds, 11 to 17, odd. 20 to 22, and then 24, 28, 31, 32. Okay, I will be after school today if anybody needs extra help. If you need to finish a test, today is the last day, so make sure you come see me.